Welcome back to my YouTube channel. We really appreciate Dr. Mrs. Ajoke for the first video she did for us. She thoroughly prepared us for qualitative analysis. We really appreciate you, ma. Thank you so much for your time. In this video now, we'll be doing the quantitative analysis, that is the titration aspect. Please watch this video to the end. Give this video a thumbs up, subscribe to this channel, and turn the bell notification so that whenever any video is up, you know. And this question is more than 80% of what you should expect. I'm assuring you that. Please get your pen and paper and write down everything you're going to see her teach us now. And I wish you success in your exam. I'm expecting you to come and comment I made A in chemistry, in physics, and in biology. Thank you. So let's go right into the video.
We are still in the business again to prepare you for what will likely come during NECO 2025 chemistry practical. This time around, it has to be on volumetric analysis. Volumetric analysis is otherwise called trigonometric analysis, or you call it quantitative analysis. Anyone you call it, you are good to go. In volumetric analysis, you have to calculate. It's not like quantitative analysis where you just identify what is present without any calculation. So what you should expect is similar to what we have here. Just sit properly and just look at what I want to present to you this afternoon. So it's very similar, it's very closely related with what you should just expect. In fact, you'll be surprised in your exam day that you have chosen the best place to look at what will be happening during volumetric analysis or trigonometric analysis of NECO in this year 2025. Look at what we have drafted for you. So we have A is a solution containing 0.10 mole per gm cube of triazole 5 acid. B contains 8.00 gram per gm cube of a mixture of sodium triazocarbonate 4 and sodium triazonitrate 5 solution. As usual, you put your A into the burette and titrate it with 20 cm cube or 25 cm cube portion of B. Tabulate your burette readings and calculate the average volume of A used. Record the volume of your pipette. So in this, you have to learn how to tabulate properly because it will help you more mark. And make sure your work is neat. Your table for your burette reading, make sure it is neat. If it is rough, you have started losing mark. So here we go. Look at how I want to tabulate my own. Because I have to start with this A now. They say I should put A with the burette. This is burette. Pour my acid, then I want to tabulate it with the base that I will pipette with my pipette. So we have the, now let me tabulate my burette reading. So you have to put A into the burette, you titrate it with 20 cm cube or 25 cm cube of B. B is your base, A is your acid. So tabulate your burette readings as I want to do it here now. And calculate the average volume of image. Record the volume of your pipette. You see, what we usually do in chemistry exam, you know, we have two questions. The first one is quantitative, is volumetric one. Then the second one is qualitative analysis. For that quantitative, you are expected to titrate 4 times. 4 times. But if you want to save time, you can titrate like 2 or 3 times. I think that one is okay. Then you should be able to be smart enough to put value for the fourth one. How do you do it? Just make sure that what you are putting does not pass plus or minus 0.20 for your titer values. So you can actually put titer values without doing 4 experiments. So just look at what I want to do now. Assuming you have done your titration, which I know all of you know how to titrate. The only problem is how to record your table. So we have burette readings now. As the question has asked us that we should tabulate our burette readings, meaning the acid the value from your initial value and your final value. So we have final direct reading. Always put units in everything. Put units to be on the safe side. Then we have initial direct reading. Put your CMQ. Then we have volume of acid boost. Volume of A boost. You still put your CMQ boost. Then the first row is your rough title. Since you have put CMQ in that place, you may not put it, but if you want to still let them know you know what you are doing, put it. No kind that. Rough title, then the first title, put your CMQ, second title, CMQ, and then third title. Put your CMQ. So from what we have titrated, what we observed, most of students they like using an initial reading to be 0.00. It is very good if you use 0.00 because it will be very easy for you to subtract the 0.00 from your final titration value. So it's very good if you put your initial at 0.00. Another thing you have to know here is your title value must have be in two decimal places. All the values you are writing two decimal places. You can see that I didn't write 0.0. I have to make it stop. Then your direct readings and calculate the average volume of failures. Record the volume of your pipettes. Now look at our direct readings in CNP. We have done our rough title first, second, third. The rough titration, you don't have idea of what your final value is likely going to be. You are just titrating. So at times you can overshoot. It can even be higher than the actual amount you expect to get after your titration. So you don't bother yourself about it. Just record whatever you have as your first rough title. Then you have to be careful when you are doing your second titration. So you see, it's a little bit coming down. You see. Then we have all these values now. Then you subtract it because I told you that you should check your title values when you are taking initial direct reading. Let it just be 0.00, 0.00 for easy subtraction. Now you can see that we still have what we have as final direct reading. By the time we are subtracting 0.00, no change in our values from the final direct readings. Now let us calculate the average volume of failures. So you let them know what you are doing to calculate the average volume of A, which is your VA used. So of course you have to take the three title values when you divide it by 3. Since they are in accordance, they have good precision. You see, the precision I'm talking about is plus or minus 0.20. Each must not pass this value. Once it passes, then you are very wrong. So you have to take it with precision and accuracy. The two of them go hand in hand in titration. So you have your 26, 25, and 60, plus 25, plus 50, plus 25, plus 40, 1 over 3. So what do we have for this? We have 0, we have
25.5.
so we now have 25.50. Don't forget your unit CN. So this is your VA. You have been able to get your VA. So that is the volume of passages. Now you need to record the volume of your pipette. Even if the question did not ask you to record it, you need to do that so that it's very easy for you to use it when you are doing your calculation. And the examiner will award mark too. I think it's even 1 mark. A whole 1 mark. You can't afford to miss that. So you put your BB equals 25. CMK. Most of titrations that we normally do in different schools, most the pet reading, the pets, they are being calibrated with this 25. So, but if your school is using 20.00 CMK, please you will not put this 25.00 CMK. But most schools, the pets volume is 25.00 CMK. So you have to take note. So that is that about what this A is asking us. Now look at this one's we have a report for you in preparatory as a preparatory class for your NECO 2025. From your results and information provided, the question is saying calculate the concentration of B in mole per dm. Calculate the concentration of B in mole per dm. Now I'm calculating this. Then I have to start with to calculate the concentration of B in mole per dm as a question instructed us. So we have this. So how do I go about this? We have two main formulae in diametric analysis or volumetric analysis. Common formula, we have other formula, I'm not saying we don't have them. But the two important ones are the first one is the one that is mole ratio. We have been hearing of CABA all over CBBB. CABA over CBBB equals NA over ND. Is that your mole ratio that you must have been hearing it when your teacher, where they are telling you in class during preparatory classes for this type of analysis. Then the second one has to it shows the relationship between your molar concentration and mass concentration and the molar mass. The mass concentration equals molar concentration times molar mass. That one is the second formula you're supposed to know. It's very important to know those two formulas. Other formulae you have learned them when you were doing mole, when you were calculating molar masses and the like, especially in chemical stoichiometry. You have learned a lot. If not, you will not be able to do in this case. And it's SS2 work. They are level. So you won't have any much problem. Just concentrate, learn your two formulae that I've just stated, your mole ratio formula and the one that shows the relationship between mass concentration, the concentration in gram per dm cube, and the concentration in mole per dm cube, which is molar concentration. Now look at it. You will now look at it. What are the results? What is my result? What is your result now? Your VA. Then the information provided. So for the question, the information says you have 0.1. So your CA as given your question, I've just gave it, is 0.1 mole per dm cube. Then the question it says the concentration of impure form of what we have is 8 of impure form. Impure, the mixture of the two salts, impure form, impure salts, the two of them. You know, they mix sodium triisocarbonate 4 plus sodium triisonitrate 5 together. So we have concentration of impure salt which is 8.0 gram per dm cube. So these are the information provided in the question for us. So this one now, since we have concentration of A, you see, we don't have mass concentration of pure B. We don't have the mass concentration except the mass concentration of the impure salt mixture. So we cannot use that formula that has to do with the relationship between mass concentration and molar concentration. So of course we are using mole ratio. We say using mole ratio. That's the only formula we can use now. So you have to indicate the formula you want to use because you will earn you mark if you use correct formula as well as you have been able to state the formula used. So we are using CA, VA all over CBBB equals NA all over NB. This is mole ratio formula, mole ratio. So your CA is given. Then we have our VA. VA is your 25.50 cm. Then the VB is your 25. Don't forget those foods, those VB, the prepared 25 cm base. So we have then from your equation of reaction, you have your Na. It's gotten from equation of reaction. This is your acid. This is Na. These two. Is that your Na now? Then your Nb is 1. You don't need to put it since it's 1 here. So it's going to be 1 and your Nb is 1. So you have your Vb, you have know everything, only this Cb. Because concentration of B is Cb, what you are calculating. Now you make Cb subject of your formula. So I believe you are very good at doing that in mathematics. So we have to do cross multiplication. We have Cb, Vb, Na equals Ca, Va, and B. Giving us that Cb equals Ca, Va, and B all over C all over Vb and A. So put in your values. So we have Ca 0.1 times Va 25.5 times Nb. Our Nb is 1. Then our Vb is 25 times 2, which is Na, number of moles of your acid in the chemical reaction. So this one gives us this 0.051 mole per gm. That is for your B. So your Cb is this in mole per gm. I think it's clear. I said you have your Ca given, you have your Va from what you titrated from your burette, from the average volume of acid that you use to have the Va. Then your Cb is what we were required, or the question says we should just calculate. And Vb is from what you pipetted from your pipette, 25 cm. Of course, Na is from your equation of reaction, which is 2, then Nb is 1, then you slot in all these values, then you have your. It remains the concentration of A in gram per gm. Now, from that information provided, it was given that the concentration of A in mole given. How to start? Let them know. It was given concentration of A in mole per dm in your question is 0.1 mole per dm. So the formula, applicable formula here is the one that shows the relationship between gram per dm and mole per dm. Gram, mass concentration. See, then the one that is molar, mole concentration. So you use that formula now. So you say using concentration in gram per dm equals concentration in mole per dm times molar mass. So it's A that they ask us to do. So you don't put any value that concern any of the values of B. You don't put it. Everything that has to do with A is what you slot in for A. Yeah, you concentrate on concentration of A in gram per dm. So look at it. So this is the one in mole per dm. Then calculate molar mass of A. So the A given is HNO3, triiodonitrate 5 acid. So you have to calculate its molar mass. So you have to say molar mass of HNO3 equals H is given that H is 1. They will always give you H is 1, O is 16, N is 14, and then C is 12, Na is 23. Everything you will use will be given. and they are there. So we have Avogadro's constant. Avogadro constant is 6.02 times 10 raised to power 23. And molar volume at STP2. Molar volume is at STP is 22.4 g. All these ones are provided. So to calculate molar mass of HNO3, it has to be 1 times 1, only one number, one atom, one atomic number, only one hydrogen, you see, is 1 times 1 plus nitrogen is 14. You see, 14. How many atoms? Only 1 times 1 plus oxygen is 16. So how many atoms of oxygen? We have 3. So it will be 16 times 3. So use your body mass and get the answer. 1 plus 14 plus 48. I think this one gives us 63. So the molar mass of your acid is 63. So you call this is the molar mass that you need to calculate. You have calculated it and you slot in to put all the values and you get your answer out. Now look at it. So it will now be concentration in gram per DNQ. DNQ is will now be 0.1 times 63. So this one gives us 66.3 gram per DNQ. So we have answered the the second part of our question. Now the third one, it says we should calculate the volume of CO2 produced at STP. How do we go about this one? You look at your formula, your equation of reaction first. See, you look at the ratio, follow a mole ratio in accordance with Gay-Lussac's law of combining volumes, although these ones are not gases, but it's still applicable to what we have here. So to calculate the volume of CO2 produced at STP, you need to look at the mole ratio of your acid to CO2 or your base to CO2 in accordance with Gay-Lussac's law of combining volumes, though it was saying that to do with gases, but it's applicable to what we have here so as to get the volume of carbon dioxide produced at STP. Now, how do we go about it? We have two. If it's acid, we are using it as 2 ratio CO2 ratio 1. You see? So we have HNO3 ratio CO2 is 2 ratio 1. So what is the molar concentration of HNO3 that we got the other time? So we got 0.05, no, it's 0.1. The molar concentration from the question given is 0.1. So 0.1, then this one now will not be what? Because it's 2 ratio 1. So that means this one will be 0.05, half of 2. I think you are getting it. If this one is 1, and this one when you multiply this one by 2 before you get HNO3, if this is half, then times 2 of this will be 0.10. So if you have this one as a mole per DNQ of your CO2, how much volume, what is the volume at STP? You know, 1 mole of any gas at STP is 22.4 DNQ. So you still apply it here. 1 mole of CO2 at STP is 22.4 DNQ. Now look at this one. So what is 0.05? How many will it be? So 0.05 will be what? That is what this question is asking us. So let's just do one short cut here. 1 mole, I want to remove the mole. 1 is 22.4. Then 0.05, I want to put this so that I can just multiply. So it means that my x will just be 0.05, do 1 times x, let me still write it, 0.05 times 22.4. So my x, 1 times x is minus, and I have 0.05 22. 1.12. You see? Don't forget the unit. If unit is not given, you have 0 for this mark here. So you put your G. So this is the volume of oxygen, CO2, carbon dioxide, it has us to do at ST. So having done that, we proceed to the next question, which says calculate the percentage purity of the mixture. So how do we do it? From the question now, it gave us 8 gram, 8.0 gram per dl for the mixture of Na2CO3 and NaNO3. So meaning this one is impurity. This the whole mass is for these two. This one will not take part in the reaction. If you look at the equation of reaction, look at the salt produced. The salt produced is sodium triiodonitrate 5. It's just additional substance added to what we have as a salt. It's not acting as a base. It's only this triiodocarbonate for 5 that is taking part in the reaction. Mean you have your acid and you have your base. So this serves as impurity. So you find how you eliminate impurity to calculate percentage purity of your mixture. So the formula is this. You find the gram of your pure form of this. So what do we do? When we calculated, we calculate concentration of B first. Concentration of B in gram per dl. How do you go about it? The same formula we use for acid that time is what we are going to use. So it will be concentration in gram per dl kilo equals concentration in mole per dl kilo times molar mass. Meanwhile, we are considering base now, it's not acid. So all values of base is what we will use for this one. It's not anything that has to do with acid. Concentration of base now is what we are dealing with. Now we have known its mole per dl cube from that calculation we did initially. You see, the mole that we got is 0.051. The one I did previously, then times its molar mass. So we need to calculate molar mass of the base too. So let's calculate the molar mass of B. So to calculate molar mass of B, you adopt that method I used for the acid, the molar mass of B. You use the atomic number and the value of each molar masses given in brackets as written here. So you have your base is Na2CO3. So it has to be sodium is 23, number of atoms 2 times 2 plus carbon 12. See, number of atoms 1. Once something is 1, not necessary to do it. Then plus oxygen 16 times 3. So this one we have 46 plus 12 plus 48. I think we have 106 for the molar mass of sodium triiodocarbonate 4. So you put in the values here, then you get your concentration in gram per dl. So we have 0.051 times this molar mass we are finding it now at 106 times 106. So it will now be
5.406.
5.406. All your calculations must be in 3 significant figures. 3 significant figures in titration in chemistry. 3 significant figures. So take note. Once it is not calculated in three significant figures, the final mark here, you have lost it. So now in gram, you put your gram per GM. Okay. So we have known this one. So this one is for only sodium triisocarbonate 4. This value now. So this is the pure concentration of this without considering this sodium triisonitrate 5. So this is the pure mass. This is the impure mass. Now calculate the percentage purity of the mixture. This is for the pure without any anything. And this for the impure combination of sodium triisocarbonate 4 and combination of sodium triisonitrate 5. So let's calculate the percentage. The percentage purity will now be the formula percentage purity will now be mass of pure, this concentration in gram per dm that you have obtained. This mass is that gram per dm. Mass of pure all over mass of impure, whatever you are calculating times 100. Percentage is always in 100. So what is the pure concentration? It is 5.140. I think it has to be this is either 1.0141. 141. That should be 141. You have to meet your sisters. 5.141 all over 8.000. One given in the question, the information provided in the question for us, then times 100. Now 64.26%. 26%. So that is percentage unit. Now calculate the mass of sodium triisonitrate 5 in the mixture. How do you do it? It's very simple. The mixture concentration is this. To calculate, don't forget you have to say to calculate the mass of NaNO3 in the mixture. Calculate it. So the total mass is 8. Total mass is 8 for Na2CO3 and plus NaNO3. Now we have obtained 5.141 for Na2CO3. So how do we get NaNO3? Simply by subtracting 5.141 from 8.0 so that we get the mass of sodium triisonitrate 5. So it has to be mass of impure form that contains the two reagents, the two salts. This is the base, this is the salt. The two of them, this is impurity, and this one is acting as a base. So mass of the impure, the concentration in gram per dm as provided in the question, minus the one we got for only this one, so that you'll be left alone with the sodium triisonitrate 5 mass concentration minus mass of Na2CO3. So mass of that's the mass of NaNO3. That's the formula. So the mass of NaNO3 equals mass of impure mixture, the mixture of the two, the total mixture which is 8, minus mass of Na2CO3, the one you got for only triisocarbonate 4. It will now give us mass of NaNO3 as the question is asking us, as 8.00 minus 5.141. So from this one we have
2.859. 59.
2.859. Three significant figures. So gram per GMK. Don't forget the unit, please. Anytime unit is not written, you have lost mark. 1 mark, half mark, 2 marks, we count a lot. So you have to take note, put your unit, appropriate unit, put it where necessary so that you have more mark and pass excellently. Now we have to calculate the percentage impurity of the mixture. The percentage purity, you say to calculate, put your number, number it appropriately. You have to calculate the percentage impurity of the mixture. So for this one, you have to know mass concentration of your impure salt. The mass concentration is what you have calculated here. It has to be all over total mass, then multiply it by 100. So use this one that you can say using mass of impure minus percentage impurity minus pure all over mass of impure times 100. So this one will give us mass of impure 8 minus, though we have done it here, but to still use formula because this formula will give you 1 mark. You still need to put formula. So you can just put this value directly, but to have mark because it's 1, 1, half till when you have your 50 marks plus your number 3 question. So we have mass of impure which is 8 minus pure, that's 5.141, that is pure all over 8 times 100. So this one gives us 2.859 all over 8 times 100. So we have 35.75. The percentage that we obtained before was 64 point what? 64 point. By the time you add the percentage purity and percentage impurity, the sum total should give you 100%. Then you know that I'm correct. You clap for yourself. I will have excellence in this my chemistry. I will be a product student in chemistry. And I take it to university and keep up the good flag. Now to calculate the last one as drafted for you as preparatory class for this year's NECO. It says calculate the amount of sodium ions in 1.00 gram of pure B in GMQ. In 1 GMQ. In 1 GMQ. And you go about this one now. You see, when they say sodium ions, they are thinking of something about Avogadro's constant. And 1 mole of any substance contains 6.02 times 10 raised to power 23. I've just made it, but if you just go back again, you will see where I put all the values. So you make use of it to calculate this amount of sodium ions. So what you do is 1 mole of any substance or substances, any one, we always is 6.02 times 10 raised to power 6.3 times 10 raised to power 23. 1 Avogadro's constant. 1 mole of any substance, whether ion, whether molecule, whether in terms of atom, it will always be 6.02 times 10 raised to power 23. Then the mole of sodium ion in that pure B what if was our mode? 0.5, 0. What? 0.05 what? 51, 0.51, where did we calculate it?
0.051.
Alright? So with the watts, the decimate x will be what? If one mole is this one, this mole, amount of mole, will be what? Or will be what? It will be how much? So you do one simple cross multiplication now, you make your x, take it as x, make it subject of the formula, and just get your sodium ion amount out. So 1, I will still do short formula 6.02 and 10 raised to the power 23. Then I put my 0.0, all the moles the same place. 51. Let me put this so that it will be like plus this is 1, 6 times 10, 6.02 times 10 raised to the power 23. And this one I've said I don't know it. This is what the person says I should calculate. So let me do cross multiply. See? So it now be 1 times x equals 0.051 times 6.02 times 10 raised to the power 23. So this one ends up giving me x equals
3.077
times
10 raised to the power 22.
See? So we have been able to calculate the amount of sodium ions in 1.00 gram of fuel in dm3, 1 dm3 of the solution. So the questions here must be well looked into. Check whatever you are calculating. Make sure if it is acid, the question requires you to calculate, you put all the values for acid so that you get right answers. And make sure where necessary you put your units to hand you complete mark. If you don't put units, you are losing marks. So these things, this quantitative analysis is about calculations. Calculation of what your teachers, what they have put inside the volumetric class for you to titrate against each other. You have unknown, you have standard solution, you have unknown solution, you titrate them, you get the amount you are putting using your VA, that is your volume of your acid. Then you start all the calculations and get the answers accordingly. From this now, at least, we don't think we that prepared you in our academy, we don't think there be anything that will be out of what we have prepared you for. I'm saying it convincingly that if you sit down, you check all these things, you watch the video repeatedly, you'll be able to catch up with whatever you want to get. I mean, A in your chemistry, a practical. And if you get A in chemistry practical or you have done it excellently well, just be so sure of yourself that you will get A in chemistry. Thank you for watching. Thanks.